Okay. Okay, so this problem indicates or states that a surveyor used a 100-meter tape to measure a distance of 2,000 meters long. So meaning to say, when the tape was used, he found out that the distance is 2,000 meters long. If the actual temperature during the measurement was 28 degrees Celsius and the thermal expansion or coefficient of thermal expansion of the tape is 0.0000116 per degree Celsius and the standard temperature is 20 degrees Celsius, determine the following. So A is the temperature correction per tape length, one tape length. B is the temperature correction for the total measured distance, and C is the true length of the line. Okay, so based on our discussion, okay, we have the formula CT is equal to K times the quantity of TA TS times L, wherein K is the coefficient of thermal expansion, TA is the actual temperature when the measurement or laying out was conducted, TS is the standard temperature. This is equal to 20 degrees Celsius. If the problem does not give you the standard temperature. L is the distance being measured, or it could be a distance laid out, or it could be the length of the tape. Okay, if we are asked to solve the temperature correction per tape length. Okay, so we are given the value K. We have also actual, we have DS. Now, what is L? Okay, so it depends. Now, it depends on the required or the requirement. So we have A. So this is, we are asked to solve the correction due to not standard temperature, which is equal to CT equal to 0.0000116. This is per degree Celsius times, you have the actual, which is 28 degrees Celsius minus 20 degrees Celsius, and L. So L here is 100 meters. Okay, why 100 meters? Because A is the temperature, correction due to not standard temperature per tape length. Okay, so because we are asked what is the correction per tape length, so that's why we have to use 100, not the 2000. Okay, so solve. Okay, simplifying that, we have this is degree Celsius or per degree Celsius, and this is degree Celsius. So the degree Celsius will be cancelled out, and you have the remaining M, okay, or the length of the line or unit, which is the meters. Okay, so we have, I will no longer show you, but I will just use the calculator. 116 times, that is 28 to 8, then times 100. Okay, so it give us a value of positive, because this is 28 minus 20, it will give us positive. You have 0.009 meters. Okay, so the positive here indicates that this situation make the tape too long. Okay, because the temperature is higher than the standard, so of course the tape will stretch, no? That make the tape into too long. Okay, so this is the answer for A. So meaning to say, in every tape length, in every one full tape length, there is a correction that must be applied or there is an error, no, of 0.009 meters, and that error should be removed by using this value. Okay, so depending whether it is measurement or laying out, no, so it can add if it's measurement, and layout or subtract if it is layout. Okay, the other problem is the correction of the total measured distance. Okay, total measured distance. So in this case, we will use the formula. You have 0.000116. I will no longer write the unit. And then you have 28 minus 20. And L, now take note, it's 2,000 meters. Okay, why 2,000 meters? Because we are asked what is the total correction of the measured distance. Okay, so you have CT, and that is equal to 0.1234116 times 8 times 2,000, and then it give us a positive 0.1856 meters. Okay, again, the positive here indicates that the tape is too long. Okay, so this is the answer for B. Or, okay, so there is also an alternative solution for this one. Okay, so alternative solutions. Okay, so that is for item B. Okay, so we are given the correction per tape length. Okay, and we are asked for B, the total correction of the distance. Okay, so if we analyze now, so the total correction of the distance is actually the correction, okay, correction per tape length multiplied by the number of tape length. Okay, the number of tape lengths when the distance is being measured or laid out. Okay, for example, you have 0.0009 meters per tape length. So if the tape was used 2 times, so it would be 0.009 times 2. Okay, so we have here that is 0.009, that is the correction per tape length, multiplied by the number of tape lengths. So for 2,000, how many tape lengths or how many times the tape was used? So of course, it would be 2,000 divided by the length of the tape. So that is equal to 2,000 divided by 100. Okay, why is it this one? Because if you measure a 2,000 distance, you will use the tape into 2,000 per 100. So you have to divide it by the number of, or by the length of the tape. So giving that, you have this value. You have 0.009 times 2,000 divided by 100, and then it will give us a positive, no? Of course, it is positive 0. Oh no, not 0. 1.8. Okay, that is let me erase. That is positive 0.18. Okay, so there is a slight difference here because from here we round off already, which is 0.009 up to 009. Okay, so if we will not round it off, no, we will give a similar value. Okay, so this is also acceptable. Okay, of course, we have the answer. Okay. Okay. So this alternative solution is quite a shortcut. No, it's a shortcut way of computing instead of using step by step. No, the other way is you have to analyze how many times you have to use the tape in measuring or laying out such distance. Okay, so for item C required us to solve the true length of the line. Okay, so if we let L prime be the true length of line, okay, or this is the corrected length of the line, then we can say that true length of the line is equal to the measured length plus the correction. Okay, what is the correction? Okay, so this correction refers to the total correction of the measured distance. Okay, so substituting the value, you have 2000 plus what is the correction? We were able to solve that. Total correction is 0.18 or positive 0.18, or it could be positive 0.1856. So we will round it off, no? Since the given is up to 2 decimal places, so we will round off also up to 2 decimal places. So we have 0.18. Okay, and therefore L prime is equal to 2000.18 meters. Okay, so this is the correct value or the corrected length of the measured distance, which is 2000 meters. Okay, so this is the answer for item C. Okay, so you might ask why when we round off the 0.1856 is give us positive 0.18, not 19. Okay, so I would like to recap, no, that when we round off numbers, we have three rules. Okay, so if the number to be dropped is above 5, so you have to if above 5, no, meaning to say if it's greater than 5, then you have to round up. Okay, the other thing is that if the number to be dropped is lesser than 5, then you have to round down. Okay, and we already learned this, no, during our elementary and high school years. Okay, the third rule that you might not be familiar is that when the number to be dropped is equal to 5. Okay, so when the number to be dropped is equal to 5, you have to round it to the nearest even number. Okay, round it off to the nearest even number. So for example, here you have the number which is 0.1856. The number to be dropped, okay, because I said it should be two decimal places. Here the number to be dropped is 5, exactly equal to 5. Okay, so what are we going to do? So as what I have said, round off to the nearest even number, so it will become 1/8. Okay, nearest even number, 8 is an even number. Okay, so the other, for example, another, how about if I have a value of 0.1756? Okay, round off to the 2 decimal places, so the number to be dropped is equal to 5. Okay, so the rule is round it off to the nearest even number, 7. What is the nearest even number of 175? The nearest even number of 175 is 1 that is 175, then that is 180. So therefore, to round it off to the nearest or to the nearest even number is 1 8. Okay, not 1 6, because 1 6 is very far than 175. No, the next is it is far or near, no, near to 1 8 or 180. No, of course we will no longer write the 0. Okay, so meaning to say, when the number to be dropped is equal to 5, it's either you have to round up, no, round up, just what we did here, we round up, we make it 1 8 instead of 1 7, or it could be round down. Okay, round down, just the same as this, 1 8 5 6, and then we make it 1 8. No, so this is round down. Okay, as long, so the no need for you to memorize whether round up or round down, basta you have to put that in your mind that you have to round it off to the nearest even number. Okay, that's why we have this 0.18, not 19. Okay, by the way, why is it plus here? Okay, why the correction is added? Okay, so it is because that the tape was used to measure. Okay, was used to measure, and it is too long. Okay, so take note that if it's too long and it is used for measurement, you have to add the correction. Okay, and if it's too long and then used to layout, then you have to subtract the correction. Okay, so I advise that do not indicate the sign here, do not bring the sign, because the sign for this correction is only a guide you that whether the tape is too long or too short. Okay, so I just put the positive here to indicate or to show you that the tape is too long. Okay, so you have to consider that this rules. Okay,